In this lecture, we are going to provide you with an overview of the data mining approach. We will first discuss what data mining is and is not. We will also discuss a number of key concepts related to data mining. Understanding the terminology in data mining is important so that everyone knows what you are talking about. There are a lot of misuse of terminology and the use of vague terms out there when people talk about data mining, so using the right terminology can avoid many unnecessary confusion. Data mining is a process which involves multiple steps leading to discovering insights in large data sets. In this lecture, we will also discuss the process of data mining, which provides you with a structured approach to this semi-creative process. But also keep this in mind, data mining is also an art, not just a rigid step-by-step process. I will provide you with an overview of two primary types of data mining techniques: supervised and unsupervised data mining, also referred to as supervised and unsupervised learning, because a lot of the data mining techniques are machine learning techniques. We will discuss the differences and the relationships between the two types of data mining. Within each type of data mining, there are multiple techniques that we will explore throughout this course. Supervised and unsupervised data mining are designed to answer different types of business questions, working with different types of input data, and achieving different types of target outcomes. The discussion of the two types of data mining will lay a solid foundation for our future discussion on the various data mining techniques used in business analytics. An important topic we will explore is similarity measures. Finding observations that are like each other is at the heart of many data mining techniques. We will discuss how to measure similarity and dissimilarity between observations or cases, and how the approaches differ between numeric and categorical data. Data mining is a key part of business analytics. Data mining is defined as the process of applying a set of analytical techniques designed to uncover hidden patterns and relationships in data, often large data sets. It is a data-driven process that embodies key techniques from business problem solving, information technology, machine learning, statistics, and other quantitative methods. So it is an interdisciplinary field. It is widely considered the scientific process of transforming data into insights for the purpose of making better decisions. As the data mining definition suggests, the input of data mining is data, which are often pre-processed raw data, and the final deliverables of the process are improved decision-making. So if you start with bad data, you will end up with bad analytical models and bad decision-making. A common misunderstanding about data mining is that it is simply complicated data queries that can be accomplished through a query language such as SQL. However, that is far from the truth. Just to give you an example, standard query tools can answer questions such as how many surgeries resulted in hospital stays longer than 10 days. It tells you information that is already in your dataset. What we just described is merely reporting and ad hoc information retrieval. The power of data mining goes far beyond these applications. Data mining is forward-looking. It helps predict events that have not happened yet. Therefore, a data mining question regarding hospital stay would be more like this: what are the important pre-operative predictors of excessive length of hospital stay? By identifying these predictors, the hospital will be able to predict the length of hospital stay before the surgery even takes place. In addition, Data mining is usually not something that can be done by just one person. It usually requires a team of experts. Analytical endeavors stand the best chance of success with input from domain data and analytical expertise. The domain expert understands the particulars of the business problem, the relevant background knowledge, context, and the terminology, and the strength and the deficiencies of the current situation, if a current solution exists. The data expert understands the structure, size, and format of the data, and the analytical expert understands the capability and the limitations of the methodologies that might be relevant to the problem. So the embodiment of these expertise might take 1, 2, or even more people. There are a few core concepts and terminology in data mining, and we are going to review them now. First, classification. Classification is the most fundamental problem of data mining. The goal of classification is to predict the class membership of a case. For example, a marketing manager may classify a list of prospective customers as potential buyers and non-buyers. A financial analyst may classify a stock into one of the following 3 classes: buy, hold, and sell. So the outcome variable, also often called dependent variable or target variable of classification problems, are categorical or binary. For example, yes or no, buy or do not buy, hold or sell, approve or do not approve, pay on time or default, and so on and so forth. The predictor variables, also called independent variables, however, can be any type of variable, numeric or categorical, but it will also depend on the data mining technique you choose. We will delve deeper into this topic later when we discuss various data mining techniques. Classification models are derived from historical data where the outcomes are known. Fundamentally, classification models are trying to answer the following question: how similar cases in the past performed, and which factors influenced the classification results in the past. There are plenty of business applications for classification. For example, credit card approval, target marketing, and fraud detection. The second and a related concept is prediction. Prediction is similar to classification in the sense that it derives prediction models from historical data, where the outcomes are known. The main difference between the 2 types of problems is that in prediction models, the target variable is numeric. For example, if you are predicting the lifetime spending of a customer, selling price of a house, or the length of hospital stay after a medical procedure, then you are building a prediction model, because the target variable is numeric. So the outcome variable for prediction model is numeric or continuous, and the predictor variables can be both numeric or categorical. Predictive analytics is a widely used term, but often misused in popular press. In data mining, predictive analytics mostly refers to classification and prediction problems because they make predictions about future outcomes based on historical data. Data and dimension reduction is another commonly used technique in data mining. Given the big data environment we are in today, data and dimension reduction is especially important. While most people would think having more data or variables is a high-class problem, in data mining, having redundant and irrelevant data and unnecessary complexity in data actually presents bigger problems than benefits. Data reduction refers to consolidation of a large number of cases into a smaller number of groups or clusters, or reduced complexity in the data. This is often referred to as cluster analysis. Cases are clustered based on their similarities in a number of traits. Dimension reduction, on the other hand, consolidates or reduces the number of predictor variables in data. This is especially useful when we are dealing with large data sets that have hundreds of variables. Common techniques for dimension reduction include principal component analysis, factor analysis, and variable clustering, some of which we will discuss later in this course. Data and dimension reduction can be a data mining task on its own, but it is often part of the pre-processing of the data for future analysis. Another key concept in data mining is association rules, also called affinity analysis. It is the study of what goes with what. It is a basic pattern recognition technique to look for common combinations of items or events. For example, recognizing that customers tend to purchase diapers with beer is an example of association rules. Similar techniques can be applied to find out which movies customers tend to stream together, which financial services bank customers tend to purchase together, and so on. A variation of the association rule is sequence analysis, which incorporates the sequence or time dimension in the analysis. It studies which events tend to follow which events. For example, a study may find that 10% of the customers who purchased a new mattress would purchase beddings within a week. That is an example of sequence analysis. As you can see, there are plenty of business applications that can benefit from association rules. Data exploration can include summary statistics, descriptive analysis, or pattern recognition. For example, calculating the means, medians, standard deviations of a dataset, or performing the recency, frequency, and monetary value analysis are all examples of data exploration. It depends on the data to tell the story or reveal any patterns or insights. Data exploration is a necessary step at the beginning of the data mining process, but it can also be used to reveal some initial insights. Data visualization explores data through graphic analysis and is an important component of any analytics project. Data visualization helps the analyst understand the data and the data quality issues and gain initial insights of the problem. During presentations, data visualization helps deliver data stories to the audience, especially non-technical audience, in an effective and engaging manner. While the focus of this course is not on data visualization, we will encounter various data visualizations to explore data and formulate data stories. Common data visualization tools include histogram, bar chart, line chart, scattered plot, heat map, and word cloud. Okay, so this is an overview of some of the core concepts and terminology in data mining that you should understand and remember.